Hello intellectuals, I am SK Thakur and you are watching this video in Digital Maths Academy. Let's continue some more identities. Number 21. So left hand side here is under root 1 plus cos theta over 1 minus cos theta. So we have to see the right hand side. Right hand side there is a positive sign. So we are going to multiply here the numerator and the denominator with 1 plus cos theta. 1 plus cos theta here, because at the right hand side we have positive sign. If there is negative sign, if there be negative sign, so we would multiply up and down by 1 minus cos theta. Now the simplification gives us here at the numerator we can see 1 plus cos theta into 1 plus cos theta. So it becomes 1 plus cos theta whole square. And at the denominator 1 minus cos theta into 1 plus cos theta, that is a plus b into a minus b equals to a square minus b square. So we can write here 1 minus cos square theta. So we have to remove its under root sign because at the right hand side there is no under root sign. So at the numerator we have already got square. So we write as it is 1 plus cos theta its whole square. At the denominator we see 1 minus cos square theta. 1 square equals to 1 itself. So 1 minus cos square theta equals to sin square theta. And sin square theta, that is sin theta whole square. So we can write here 1 plus cos theta over sin theta and its whole square. Then you can remove under root sign as well as square. So we can write here 1 plus cos theta over sin theta. Now we are going to separate the base, that is 1 by sin theta plus cos theta over sin theta. And 1 by sin theta gives us cosec theta. And cos theta by sin theta gives us cot theta, which is our right hand side. Proved. Identity number 22. We have 1 plus sin theta, 1 minus sin theta inside under root sign, and you can see sec theta plus tan theta is at the right hand side. So we are going to multiply the numerator and the denominator by 1 plus sin theta, right? Because plus is at the right hand side. So similarly as we have done in the question number, in the identity number 21, same here we get 1 plus sin theta whole square at the numerator and 1 minus sin square theta at the denominator. So we can prove as the question number 21. Right, so finally you can get here 1 plus sin theta by cos theta when you remove the under root sign of the square, and you can get the right hand side very easily. In 23, we see here is 1 minus cos theta upon 1 plus cos theta at the left hand sides, and there is a minus sign at the right hand side. So we multiply up and down by 1 minus cos theta and 1 minus cos theta. So we get 1 minus cos theta whole square at the numerator and 1 square minus cos square theta at the denominator. So we simplify as we have done in the identity number 21 and 22, and you can get easily the right hand side, that is cosec theta minus cot theta. Number 24. So we are going to choose left hand side here. Left hand side is 1 minus sin to the power 4 theta over cos to the power 4 theta. So at the numerator we can write 1 square minus sin square theta whole square. And at the denominator as it is, that is cos to the power 4 theta, and we apply a square minus b square formula at the numerator. So we write here 1 plus sin square theta, that is a plus b, and 1 minus sin square theta, that is a minus b. At the denominator we write cos to the power 4 theta. Now we see 1 minus sin square theta gives us cos square theta. So we write here 1 plus sin square theta as it is. And here we can write cos square theta. And cos to the power 4 theta, we can write it as cos square theta dot cos square theta. So 1 cos square we can cut up and down. And remaining we write here, that is 1 plus sin square theta over cos square theta. Now we are going to separate the base, 1 by cos square theta plus sin square theta over cos square theta. So 1 by cos square theta gives us sec square theta, and sin square by cos square gives us tan square theta. But we have tan square theta only at the right hand side, so we are going to change sec square theta into tan square, that is 1 plus tan square theta, and plus tan square theta. So here tan square theta plus tan square theta becomes 2 tan square theta. So finally we have 1 plus 2 tan square theta, which is at the right hand side, and proved. Similarly, in the identity number 25, we choose left hand side, that is 1 minus cos to the power 4 theta over sin to the power 4 theta, and 1 minus cos to the power 4 theta can be written as 1 square minus cos square theta its whole square, over we can write sin to the power 4 theta. Then a square minus b square formula we are going to apply, that is 1 plus cos square theta and 1 minus cos square theta, that is a plus b into a minus b. At the denominator we write here sin to the power 4 theta. Now we write here 1 plus cos square theta and 1 minus cos square theta equals to sin square theta. At the denominator we have sin to the power 4 theta, so sin to the power 4 theta can be written as sin square theta dot sin square theta. So we can cut sin square theta very easily. Then we have here remaining is 1 plus cos square theta over sin square theta. Now the separation of the base, 1 by sin square theta plus cos square theta over sin square theta. Now 1 by sin square theta equals to cosec square theta, and cos square by sin square equals to cot square theta. But we have only cot at the right hand side, so cosec square theta is changed into cot square theta as 1 plus cot square theta and plus here cot square theta. So cot square plus cot square gives us 2 cot square. So finally we have here 1 plus 2 cot square theta, which is right hand side. And then you can write here proved. Number 26. So we are going to choose left hand side. Left hand side equals to sec to the power 6 theta plus tan to the power 6 theta. Over we write here sec square theta plus tan square theta. So we write sec to the power 6 theta as sec square theta whole cube plus tan square theta whole cube. Over at the denominator as it is, nothing any change, sec square theta plus tan square theta as it is. So we apply a cube plus b cube formula at the numerator. So we write here a plus b, then a square means sec square theta whole square, a square, minus ab, minus a means sec square theta dot tan square theta, plus b square means you can write here tan square theta its whole square. And over at the denominator we write here sec square theta plus tan square theta. So we know one formula, the formula is a cube plus b cube equals to a plus b, a square minus ab plus b square. That's the formula, so we apply here this formula. Now we see here the denominator and the numerator, sec square theta plus tan square theta, yes, we can cut. And remaining we have here sec square theta minus sec square theta dot tan square theta plus sec square theta whole square. So again we apply formula here, a square plus b square, right? So a square plus b square has two formulae. A second formula we apply. First formula is a plus b whole square minus 2b, another is a minus b whole square plus 2ab. So we apply here a means sec square theta, minus b means tan square theta its whole square, a minus b whole square, plus 2ab. Plus 2ab means what now? 2 sec square theta dot tan square theta, and we have already here minus sec square theta dot tan square theta. Now we see here sec square. Now we can write the formula here. First of all, the formula is here a square plus b square equals to a plus b whole square minus 2ab, and another is a minus b whole square plus 2ab. So we write the second one. You know why? Because sec square theta minus tan square theta equals to 1. So we apply the second one formula. Now the remaining we have here we can see sec square theta minus tan square. This part gives us 1, so 1 square, and plus 2 sec square dot tan square minus sec square dot tan square equals to plus sec square theta dot tan square theta, right? Because 2x minus x is equal to minus x. So finally we have here 1 plus sec square theta dot tan square theta, which is our right hand side, and then proved. Identity number 27. So here we are going to choose the right hand side. And right hand side we have sec theta minus tan theta and its whole square. So sec theta can be written as 1 by cos theta and tan theta as sin theta by cos theta and whole square. Now we take LCM. LCM is just cos theta. So you can write here 1 minus sin theta, and we write square up also and down also. So now here 1 minus sin theta, we write here 1 minus sin theta whole square. And now here we have cos square theta means 1 minus sin square theta. So we see here 1 minus sin theta whole square equals to 1 minus sin theta into 1 minus sin theta, because x square equals to x into x according to the condition. So at the denominator we have 1 minus sin square theta, so we can write here 1 plus sin theta into 1 minus sin theta. That is a square minus b square equals to a plus b into a minus b. So we see one factor we cancel up and down. Remaining we have here 1 minus sin theta over 1 plus sin theta, which is equal to left hand side, and then you can write here proved. Identity number 28. So it's a very easy question. So we choose here left hand side. Left hand side equals to sine to the power 3 theta minus cos to the power 3 theta over sine theta minus cos theta. So we apply AQ minus BQ formula at the numerator. So we have here A, that is sine theta, B, that is cos theta, A minus B, then A square. A square means you can write here sine square theta, A square, plus AB. Plus A means we write here sine theta dot cos theta, and plus B square means cos square theta. Yes, we write. And at the denominator we have here sine theta minus cos theta. So one factor you can cut up and down, and remaining we have here sine square plus cos square. That's the so famous formula, sine square theta plus cos square theta equals to 1. So we write here 1 plus, write here sine theta dot cos theta, which is our right hand side. So it's a very easy but very important. So that is the right hand side and proved. Identity number 29. So is it 29? So here we are going to choose right hand side. Right hand side equals to sec theta minus tan theta, its whole square. So sec theta equals to 1 by cos theta, and sin theta, tan theta equals to sin theta by cos theta, and its whole square. So we are going to take LCM. LCM of cos theta and cos theta is cos theta itself, and here 1 minus sin theta, and we write square up also and down also. Now 1 minus sin theta whole square equals to 1 minus sin theta whole square, right? We are not going to apply formula minus whole square here, and cos square theta equals to 1 minus sin square theta. So at the numerator we write two factors, 1 minus sin theta into 1 minus sin theta, and 1 minus sin square theta equals to 1 plus sin theta into 1 minus sin theta, because a square minus b square equals to a plus b into a minus b. So we see one factor cancel one factor, and remaining we have here 1 minus sin theta divided by 1 plus sin theta. It's equal to left hand side, and we can write here lastly proved. So number 30. So we can choose left hand side or right hand side, doesn't matter, both are equal. So let's choose left hand side. Left hand side is cos theta plus cos beta over sin theta minus sin beta. So we multiply up and down either by sin theta plus sin beta or cos beta minus cos theta. So we can multiply by any factor. So let's multiply up and down by sin theta plus sin beta. Here also sin theta plus sine beta. Now we are not going to do any change at the numerator, so that we can write here cos theta plus cos beta, and here also we have sine theta plus sine beta, and at the denominator we see sine theta minus sine beta, sine theta plus sine beta. That's we have in the form of a minus b, a plus b. So we write here a square minus b square, that is sine square theta minus sine square beta. Yes, we can write a minus b plus b equals to a square minus b square. So numerator, no any change, so we write cos theta plus cos beta, and another factor we have sine theta plus sine beta. Now we are going to change sine square into cos square, because we have cos only at the right hand side at the denominator. So sine square theta gives us 1 minus cos square theta, and sine square beta gives us 1 minus cos square beta. So here is minus, we have to change the sign 1, and then we write here plus cos square beta. Now here plus 1 minus 1 will cancel, and the remaining we write numerator as it is. So we have here cos theta plus cos beta, then we have here sine theta plus sine beta, and here at the denominator there is a minus cos square theta plus cos square beta. So write cos square beta at first, so we write here cos square beta positive at first minus cos square theta. Now we apply formula a square minus b square at the denominator, numerator as it is. So we have here cos theta plus cos beta, and here sine theta plus sine beta, and now here a square minus b square, so we apply formula a square minus b square as a plus b into a minus b. So we have cos beta plus cos theta, then we have cos beta minus cos theta. So we can cut up and down cos theta plus cos beta. We see here these two factors will cancel, because cos theta plus cos beta and cos beta plus cos theta same thing, x plus y, y plus x. So remaining we have here sine theta plus sine beta over cos beta minus cos theta. With that we have right hand side is put. So number 32. So we are going to choose left hand side here. Left hand side is sec theta minus tan theta plus 1 over 1 plus sec theta plus tan theta. Right? So we are going to replace 1 by sec square theta minus tan square theta. So we write here sec theta minus tan theta, and plus at the place of 1 we write here sec square theta minus tan square theta, because sec square theta minus tan square theta equals to 1. And we do not do any change at the denominator, so we have here 1 plus sec theta plus tan theta as it is. Now a square minus b square formula we apply, so sec theta minus tan theta we write, and here a square minus b square equals to, we can write here sec theta plus tan theta and sec theta minus tan theta. At the denominator as it is, we are not going to do any change, so 1 plus sec theta plus tan theta. Now we see sec theta minus tan theta is common, right? So we can take here sec theta minus tan theta, we take common. So when we take common, so at the place of sec theta minus tan theta we get 1 plus, and here sec theta minus tan theta came as common, so we have here 1 plus sec theta plus tan theta, and at the denominator we have here 1 plus sec theta plus tan theta. So we see one factor will cancel up and down, right? And the remaining we have here sec theta minus tan theta. So we have the middle part. So we are not going to write middle hand side, because we have only two sides, left side and right side. So we write here middle part, okay? That's equals to middle part. And now from the middle part we are going to prove the right hand side. So again you can write here sec theta equals to 1 by cos theta, and tan theta equals to sin theta by cos theta. So we take cos theta common, and we have here 1 minus sin theta, which is our right hand side, and you can write here proved. Number 33. So we are going to choose left hand side here. we can choose right answer also. Same. So sec alpha minus tan alpha plus 1 over sec alpha minus tan alpha minus 1. So here at the place of 1 we write sec square minus tan square up also and down also. So we write here sec a alpha minus tan alpha, and at the place of 1 we write here sec square alpha minus tan square alpha, because that's equals to 1. And at the denominator also we write the same here, sec alpha minus tan alpha, and we write here minus, we write here minus here, and inside the bracket we write here sec square alpha minus tan square alpha. So now we apply the formula a plus b minus b here. So we write here sec alpha minus tan alpha, we can write inside the bracket also, and plus a plus b minus b. So we write here sec alpha plus tan alpha and sec alpha minus tan alpha. Just formula of a square minus b square, that's equal to a plus b and a minus b. Denominator same, sec alpha minus tan alpha, and here also we apply the same formula, that is a plus b means sec alpha plus tan alpha and sec alpha minus tan alpha. Yes, we can write sec alpha minus tan alpha. Now we are going to take common. At the numerator common is sec alpha minus tan alpha, so we write the common here sec alpha minus tan alpha, right? So when you take common we have here 1, here at the place of sec alpha minus tan alpha we write here 1, and plus means no sign change, so we write here as 1 plus sec alpha plus tan alpha. And at the denominator sec alpha minus tan alpha we take common, then we have here 1, here is minus, so sign will be changed, so sec alpha becomes minus sec alpha, and this plus tan alpha becomes minus tan alpha. So in this way we see one factor will cut up and down, that is sec alpha minus tan alpha, that will cancel. Remaining we have here 1 plus sec alpha plus tan alpha, and here at the denominator we have 1 minus sec alpha minus tan alpha, right? That's our right hand side, and you can write here truth. Number 34. So we are going to choose left hand side. Left hand side we have 1 minus sine theta plus cos theta. At the denominator we have sine theta plus cos theta minus 1. So we have to bring 1 plus cos theta by sine theta. So we are going to divide up and down by sine theta here. So we write here 1 minus sine theta plus cos theta over sine theta, and at the denominator we write sine theta plus cos theta minus 1 by sine theta. Yes, we can divide up and down by sine theta. Why? Because we have to bring 1 plus cos theta by sine theta means we have to bring cosec theta plus cot theta, right? So here we are going to separate the base. So here 1 by sine theta, here we can see 1 by sine theta becomes cosec theta, right? So you can write here cosec theta when you separate the base. Then you can write here, let's separate the base first of all, right? So we separate the base first of all. So we can write here 1 by sine theta minus sine theta by sine theta plus cos theta by sine theta. And at the denominator same. Actually we can write here sine theta by sine theta plus cos theta by sine theta minus 1 by sine theta. So we are going to separate the base here. Now we can write here 1 by sine theta is cosec theta, and here minus 1 we can write, and then you can write here plus cot theta because cos by sine is cot, and at the denominator we write here sine by sine means 1 plus cos by sine, we can write here cot, yes, cot theta, and minus cosec theta. Now we are going to replace 1 here, we can see minus 1, so we write cosec theta plus cot theta as it is. Now minus 1 means we can write inside the bracket for 1 cosec square theta minus cot square theta. Yes, because cosec square theta minus cot square theta equals to 1, and we are not going to do any change at the denominator, so we have 1 plus cot theta minus cosec theta. Now a square minus b square formula we apply at the numerator. So we have here cosec theta plus cot theta inside the bracket. Yes, we can write, and a square minus b square equals to, here we can write cosec theta plus cot theta and cosec theta minus cot theta. A plus b minus b. We have applied this formula several times, and 1 plus cot theta minus cosec theta as it is. Now cosec theta plus cot theta we are going to take common, so we can write here cosec theta plus cot theta, it's a common, and we have here 1 minus, and then sign will change, so we can write here minus cosec theta and minus times plus cot theta, right, because cosec theta plus cot theta is common, and down of that we have here 1 plus cot theta minus cosec theta. So we see one factor will cut up and down, so this factor will cancel. Remaining we have cosec theta plus cot theta, and cosec theta gives us 1 by sin theta, and cot theta gives us cos theta by sin theta. So when you take LCM is sin theta, so we can write here 1 plus cos theta, which is equal to right hand side, and finally you can write proved. 35 number. So such type of identity can be solved by transposing. So we have to first write here transposing. Okay, so here is now transposing the terms we have. So we are going to transpose means here like terms we have to group one side, and unlike terms we have to group another side. Like terms we have to group. So we can write here cos alpha by sin alpha plus cos beta, and we see here right hand side, so this becomes minus, so we can write here minus cos alpha by sin alpha minus cos beta. Now these two terms become like, so we have to group like this, and then we can write here cos beta at the right hand side, and we have here sin beta plus cos alpha, and similarly there this part will go to another side, so we can write here minus cos beta over sin beta minus cos alpha, right? So we are going to transposing here, so we have to bring here to the left hand side, okay, and this term we are going to bring at the right hand side. Now we are going to choose left hand side, right? So left hand side here, left hand side equals to here cos alpha over sin alpha plus cos beta minus cos alpha over sin alpha minus cos beta. Okay? So we are going to take LCM here. LCM equals to sin alpha plus cos beta, and here sin alpha minus cos beta. So when you do the simplification, you can write here cos alpha, and here we have sin alpha minus cos beta. So likewise we have here minus cos alpha, and we write inside the bracket sin alpha plus cos beta. So we are going to open the bracket at the numerator. So when you open, we can write here cos alpha dot sin alpha minus cos alpha dot cos beta. Here also you open the bracket, so we can write here minus cos alpha dot sin alpha, and plus minus minus we write here cos alpha dot cos beta. And at the denominator we see here a plus b, a minus b, so you can write here sin square alpha minus cos square beta, right? Now we see here actually cos alpha dot sin alpha will cancel up and down, so we cancel this factor and that factor. Okay, cos alpha dot sin alpha, yes, we can cancel. Remaining we are going to write over here. So remaining you have minus cos alpha dot cos beta minus cos alpha dot cos beta, so we write here equals to minus 2 cos alpha dot cos beta over, we have here sin square alpha minus cos square beta, so sin square alpha becomes 1 minus cos square alpha, and cos square beta equals to minus 1 plus sin square beta, right? Now we have right hand side, and right hand side we can take LCM of right hand side, right? So here sin beta plus cos alpha and sine beta minus cos alpha. As you can take LCM, then we will have cos beta times sine beta minus cos alpha, and here is minus, then cos beta, we can write here sine beta plus cos alpha. So we have to do the simplification here. Just open the brackets. So we have here cos beta dot sine beta minus cos beta dot cos alpha. So open the bracket by minus cos beta. So we can write here cos beta dot sine beta, and plus minus minus sign we can write, and then we can write here cos beta dot cos alpha. So at the denominator we have sine beta plus cos alpha and sine beta minus cos alpha, that is in the form of a plus b minus b. So you can write here sine square beta minus cos square alpha. So now we can see here cos beta dot sine beta and cos beta dot sine beta, plus and minus can be cancelled. So remaining we have minus cos beta dot cos alpha and minus cos beta dot cos alpha. So you write here minus 2 cos beta dot cos alpha over sine square beta minus cos square alpha. So when you see the left hand side, the simplification of the left hand side, we have here simplification of the left hand side is minus 2 cos alpha dot cos beta by sine square alpha minus cos square beta. So we have got the same, right? So just we can write here minus 2 cos alpha dot cos beta according to the left hand side, and sine square beta minus cos square alpha, that's equal to the left hand side. Simplification of the left hand side, then you can write here proved. Just you can see left hand side and the right hand side both are equal. Left hand side is this part, right? Left hand side and the right hand side, just you can see this part. So left hand side and right hand side both are equal, so you can write here proved. So number 36, so we can choose left hand side or right hand side, doesn't matter. So let's choose left hand side. Left hand side equals to 2 minus cos square theta times 1 plus 2 cot square theta. So we are going to change cot square into sin and cos, that is cot square equals to cos by sine. So 2 minus cos square theta, and here 1 plus, we can write 2 cos square theta by sin square theta. Now 2 minus cos square theta as it is, and the simplification of the second part, we get here sin square theta plus 2 cos square theta over sin square theta. So sin square theta is the denominator of second factor, so this becomes the denominator of the first factor. So we can write here 2 minus cos square theta by sin square theta we can write. So that is now here sin square theta plus 2 cos square theta, and denominator nothing, right? So now we are going to change the separate the base here, that is 2 by sin square theta minus cos square theta by sin square theta. Yes, we are going to separate the base, and here sin square theta plus 2 cos square theta, yes we can see. So we are going to change cos square into sin square according to the right hand side. So we write here sin square theta plus, we can write here 2, and inside the bracket we write here 1 minus sin square theta, right? So we can do. Now we are going to do now 2 by sin square theta means 2 cosec square theta, and minus cos square by sin square means cot square theta, and here we are going to open the bracket. So sin square theta plus 2 minus 2 sin square theta, yes you can do. Now we are going to simplify. So simplification is like this here. So 2 cosec square theta, but we have only cot square at the left hand side, so change cosec square into cot square, that is 1 plus cot square theta, and then minus cot square theta, right? This is the first factor, and secondly we have here sin square theta minus sin square theta, because sin square minus 2 sin square means minus sin square theta, we can write minus sin square theta, and then we have here plus 2, isn't it? Now we open the brackets, so 2 plus 2 cot square theta minus cot square theta, and second part we have here 2 minus sin square theta, so here should be theta, right? And now the simplification here, we can write 2 at first, and 2 cot square theta minus cot square theta equals to plus cot square theta. And here we have 2 minus sin square theta, which is equal to the right hand side. And finally you can write root. So number 37. So 37 number, we can choose any side. So let's choose left hand side. Left hand side is 3 minus tan square x, and we have here 4 cos square x minus 3. So here also you can write 3 and tan square as sin square x by cos square x. So it is x. Next one we have 4 cos square x minus 3. So simplification gives us 3 cos square x minus sin square x over cos square x, and we have another factor as 4 cos square x minus 3. So we are going to shift cos square x as the denominator of the second factor. So we write here 3 cos square x minus sin square x, and here it becomes 4 cos square x minus 3 over cos square x. Now we see there is a sin square only, at the right hand side in the first factor. So we change cos square into sin square, that is 1 minus sin square x, and here is already we have sin square x. So this is the first factor. And second factor, we separate the base. So we have here 4 cos square x by cos square x minus 3 by cos square x. Now just open the bracket. So we have here 3 minus 3 sin square x minus sin square x. Then you have here cos square x you can cut. So we have here 4 minus 3 sec square x, right? Because 1 by cos square means sec square, so we can do as it is. Now just simplifications, we have here 3 minus 4 sin square x. So first factor, of the right hand side we got. Now secondly we have here 4 minus 3 sec square x, but we have tan square, so we are going to change sec square into tan square. That is 3 and 1 plus tan square x we write, because sec square equals to 1 plus tan square. Now we can write here 3 minus 4 sin square x and open the bracket here, that is 4 minus 3 and minus 3 tan square x you can write. And then we have here 3 minus 4 sin square x, and now here 4 minus 3 equals to 1 minus 3 tan square x. So this is our right hand side. So you can write right hand side, then root. So number 38. So we can choose any side. So let's choose left hand side. Left hand side equals to 1 plus cosec a dot tan b, right? Then here 1 plus, and there is a whole square also, whole square, and 1 plus cosec c dot tan b, and its whole square. So first step, what we can do here, 1 plus, we can write here cosec square a dot tan square b. At the denominator we write here 1 plus cosec square c dot tan square b. Now we are going to change cosec square into cot square. So we can do now here 1 plus, here cosec square equals to, you can write here 1 plus cot square a, and then we have here tan square b. At the denominator also we can write here 1 plus, and cosec square c means 1 plus cot square c dot tan square b, yes you can write. Now we are going to open the bracket. So we write here 1 plus tan square b into 1 equals to tan square b plus cot square a dot tan square b, we can write. And at the denominator we can write here 1 plus, again now tan square b plus, we can write here cot square c dot tan square b. So we know that here 1 plus tan square b equals to sec square b, right? Sec square b, and plus cot square A dot tan square B, and at the denominator we write here sec square B, here also sec square B, and plus cot square C dot tan square B. Now we are going to do one technique. The technique is we are going to multiply up and down by cos square B. Right? We are going to multiply up and down by cos square B. Why? Because cos square B into sec square B equals to 1. Then we multiply. Right? So sec square B into cos square B. First we write here. That becomes sec square B into cos square B, and plus here we have cot square A, then you have tan square B, so we can write here tan square B means sin square B by cos square B, and into we can write here cos square B. Right? And then we can write here sec square B into cos square B. We write cos square B plus cot square C we have here, cot square C, and tan square B equals to sin square B by cos square B into cos square B. Yes, you can write. Now sec square B into cos square B gives us 1, because sec B into cos B equals to 1, 1 square equals to 1. Now we can cut here cos square B and cos square B. Here also we can cut, and the remaining we have here 1 plus here cot square A dot sin square B, and at the denominator we have here also 1 plus cot square C dot sin square B. So we have to arrange it according to the right hand side. So we have here 1 plus, we can write cot A dot sin B, its whole square, over 1 plus cot C dot sin B and its whole square. That's equal to the right hand side, hence root. Number 39. So we are going to choose left hand side. Left hand side is 1 plus cot theta minus cosec theta, and 1 plus tan theta plus sec theta. So we change cot into cos by sin, as we can write here cot theta as cos theta by sin theta minus 1 by sin theta. Yes, you can write. Next factor we can write here 1 plus tan as sin theta by cos theta plus 1 by cos theta. So now we are going to take LCM. LCM is here sin theta. Then we have here sin theta plus cos theta minus 1. Next factor we have here cos theta. Then we have here cos theta plus sin theta plus 1. Now here is the multiplication, so we are going to multiply. So we have here minus 1 and plus 1. So we can write here as sin theta plus cos theta in one factor. Inside the bracket you can write minus 1, and we can write them inside the curly bracket like that. So we write here sin theta plus cos theta, and then you can write here minus plus 1. Here is a plus 1. So this is the way of multiplying if we have the different sign. Then we have here sin theta dot cos theta. Now when you multiply, then you can see here sin theta plus cos theta minus 1 and sin theta plus cos theta plus 1. So we can apply formula a plus b minus b as a square minus b square. So at the place of a we have sin theta plus cos theta, so a square, then minus b square, that is 1 square. At the denominator as it is, that is sin theta dot cos theta. So now we are going to simplify it. So a plus b whole square, yes, we can apply its formula. So we can write here a square means sin square theta plus 2 sin theta dot cos theta plus cos square theta. And then we have 1 square is 1. And at the denominator we have sin theta dot cos theta. Now we see sin square and cos square gives us 1. So we can write here 1 plus 2 sin theta dot cos theta. There is a minus 1. Then you can write here sin theta dot cos theta. So we can see plus 1 minus 1 will cancel. Remaining we have here 2 sin theta dot cos theta divided by sin theta dot cos theta. So you can easily cut sin theta and cos theta up and down. Remaining we have only 2, that's equal to the right hand side, and we can write here root. So number 40. So we are going to choose left hand side. So left hand side equals to sine theta plus sec theta and its whole square. Then we have here cos sec theta plus cos theta and its whole square. So we are going to apply formula a plus b whole square. So we can write here sine square theta plus 2 sine theta dot sec theta plus sec square theta, isn't it? And plus cos theta whole square, we can write here plus, then we can write cos sec square theta plus 2 cos sec theta dot cos theta plus cos square theta, isn't it? Now here sine square theta, we see sine square theta and cos square theta, that gives us 1, so we can write here 1, right? And after that we have here 2 sine theta dot sec theta and 2 cos sec theta dot cos theta. So we are going to take 2 common between them. So let's have 2 common, right? So we have here 2 sine theta, sorry, we have taken the common. So we can write here only sine theta dot sec theta and plus cos sec theta dot cos theta, because we have taken common 2 between these 2 terms. And after that we have here sec square plus cosec square. So sec square means 1 by cos square and cosec square theta means 1 by sin square theta. Now we can write here 1 plus 2 and we write here sin theta as sin theta and sec theta means 1 by cos theta, so it becomes by cos theta, and plus here also cosec theta means 1 by sin theta, and here we have cos theta by sin theta. So we are going to change sec and cosec into sin and cos, and here we are going to take LCM. LCM will be cos square theta dot sin square theta. So we have here sin square theta plus cos square theta. So just simplification now, 1 plus 2, and here we have cos theta dot sin theta LCM, and we have here sin square theta plus cos square theta, alright, plus sin square theta plus cos square theta equals to 1 over, so at the denominator we write cos square theta dot sin square theta. So here we have sin square. Now we have here equals to, you can write 1 plus here 2 and sin square dot cos square equals to 1, so we can write here 2 over cos theta dot sin theta and plus 1 by cos square. We have 1 by cos square means we can write here sec square theta, and 1 by sin square theta means cosec square theta, right? So we have here 1 plus, we can write here 2 sec theta dot cosec theta plus sec theta dot cosec theta, you can write here sec theta dot cosec theta, its whole square. Now it is in the form of a square plus 2ab plus b square. For a is sec theta, and for b we have here cosec theta. So you can write here 1 plus sec theta dot cosec theta and its whole square, and which is our right hand side, and then you can write here root. Kindly not to forget to like, subscribe and share my video. Thank you. Have a nice time.